Good morning, all. On behalf of DYPIMS, that is Dr. DY Patil Pratishthan, DY Patil Institute of Management Studies, and Institute for Advanced Computing and Software Development, that is popularly known as IACSD Pune. Myself, Keshav Kumar, I head the placements and marketing at IACSD. So this is a joint initiative from DYPMS and IACSD. DYPMS is a management college offering 2-year program of SPPU uh, that has specialization in HR, marketing, finance, operations, analytics. And IACSD, it's an authorized training center of CDAC, Pune, which offers programs like PG diploma courses. One is Diploma in Advanced Computing, one is Diploma in Big Data Analytics, one is Diploma in IT Infrastructure System Security. So this is the brief background of the institutions on behalf of which we are organizing this workshop expert session. Now, this session will go on for 2 days, today in the first half and then the second half. And tomorrow there will be one single session right from 10 to 2 p.m. Because being an year end, so we have clubbed both the sessions tomorrow. And the resource person for the session, both the days session, is Dr. Shantanu Pathak. So just to give a brief about our resource person, Dr. Shantanu Pathak, he is a PhD in machine learning, and that is he completed in 2020. He has done his engineering, then post-graduation, that is his master's in IT, and he has years of experience closing to somewhere around 15 to 20 years. And he has core expertise in areas like machine learning, NLP, deep learning, Python, etc. Currently, he is associated with our institute as a trainer, course coordinator for big data analytics at IACSD Akudi. He has been engaging the students on various topics which is related with artificial intelligence and data science. And he has been a professor at PICT also in the past, to say something about his career background. And of late, he has been engaging the students for taking the initiative to execute some of the novel projects in the field of data science and data engineering. Welcome, Dr. Shantanu.
Yes, sir. Thank you. Thank you very much, Yasho, sir.
Good morning. And
Yes, good morning. Yeah.
so with this,
Yes.
now uh, I would once again welcome all the participants and request you to take as much advantage as you can. And I will hand over the proceedings to Dr. Shantanu.
Yes. Yes. Thank you, sir. Thank you very much. So, hi everyone. Welcome. And I am happy to see you all, 79 participants here. I'm thrilled, and I was informed that there are some PhDs I can see here. There are some doctors have joined, and obviously there are many enthusiastic students who have joined, and it's very nice to know that so many of you are interested in this topic of machine learning. So uh, my plan is, let's say today, first half, we will be talking about introduction to ML, and then we will be talking about practical, more details about supervised learning and all that. And tomorrow we will be discussing unsupervised learning majorly, and you know recommendation systems and all that, and implementation and AWS. So shortly I will be also giving you a survey, so which I would like people to fill, okay, so that I will come to know about the audience. First we will have the introduction session to ML, and then okay, then what we will do is we will try to have some understanding about the audience, so that we will know where are the focus areas where all of you require that kind of inputs. So we would be focusing on those things. Okay. Okay, everyone. So let's start with machine learning. Okay. So many of you have heard about AI, right? You heard about so many things about AI nowadays, especially you know, Chat GPT. Yeah. How many of you use Chat GPT? Type Y in the chat box. You use Chat GPT? Wow, many of you. Yeah, that's nice. Nice to know that. So there is AI. AI is a lot being talked about nowadays, and people, yes. So people are very, very much interested in AI, and one of the core branch of AI is machine learning. Okay. So so that's why we are talking about machine learning today, and we will be kind of connecting why we require machine learning, where we position ourselves in machine learning, what is AI as a whole thing, where AI stands, and where machine learning comes into picture, and all that we will discuss. Okay, so nowadays, for those who are like students, you should understand that ML has a lots and lots of role to play. AI has a lot of role to play. Uh, Soon, like when the computers started, way back in few, I think 1920s, 1920s, 1940s, computers started their, like, people started using computers, and initially people thought that computers means some people will use them, everybody is not going to use computers, and something like that. People thought that some industry will use computers, some expert people will use computers, and like that. But now today we stand here into 2024. Okay, so we stand at the door of 2024, almost 100 years, or maybe 80 plus years, 80 years past that computer innovation, and today every one of us is using computers. So guys, similarly, AI has been talked about since many years. AI, ML, okay, these things, they have been talking, people are been talking about this since 1950s, or maybe theoretically, if we see, the theoretical definition of AI was defined in 1920s roughly. So since many years, people have been talking about AI, machine learning, and all that, and it is going to be really making a lot of changes in us, okay, in next few years. So yes, it's nice to see all of you. We will have a lot of discussion on machine learning and AI, and some perspectives to it. How are the different algorithms, some implementation part as well, some coding part as well, and more of a conceptual part. We would like to clarify, okay, those things. So this is the plan. So it's nice to see all of you here. Okay, so let's begin our discussion. So machine learning, field of study that gives computers the ability to learn without being explicitly programmed. So in 1959, Arthur Samuel defined machine learning to say that without writing a program, if you can do something with the computers, if you are able to make the computer do something without writing an explicit program for it, then that is a machine learning. So understand here, whenever we are talking about, one very important thing, whenever we are talking about machine, okay, so this machine word, many a times people may think that this is a physical machine, but actually always this machine is going to be a software. So keep that in mind, that whenever Arthur Samuel, he was saying that machine is going to learn or computers are going to learn. So what part of the computer is going to learn? The software part of the computer is going to learn and not the hardware part. So it would never be that some hardware machine or some kind of a boiler or maybe kind of a fan is going to learn. Okay, the software part of it would be learning. So keep that in mind. Okay, so that is machine learning. So what is the difference between classical programming and machine learning? There are a few things. Okay, one thing, you have, how many of you know at least one programming language? Maybe you know C or C++, or you know Python, or you know some programming language. Type Y in the chat box. At least you know one of the programming languages. Okay, that's great. That's great. So yeah, okay. So that's great. Almost 88 and there's 20 people. So quite good percentage, right? Maybe 30-40% people, they know some programming language. That's nice to know that. Oh, there are some people from purely R programming. That's nice to know that. Okay. Okay. Okay, so understand, in programming, you're supposed to write some rules and given some sample data. Let's say 1 + 1 = 2. You want to do this. So what do you write a program? You say A is equal to 1, B is equal to 1, and you say C is equal to A plus B, right? Do this stuff. Okay, you have some rules. There is an addition rule. You know that when 1 and 1 is there, then there is addition, it gives 2. And there is some sample data being given. 1 + 1 is 2, and maybe 2 + 2 is 4, something like this. There is some sample data being given and there are some rules. And what do you get is the output is the answer. So you write the program. Okay, so you write the program and you write this stuff, and by this, whenever there is some input, it is always going to give the output. Okay, always going to give, follow the rules exactly as it is. Now in machine learning, what are we targeting? In machine learning, we are targeting that the output of machine learning is patterns and rules. So we don't know the rules. Let's say we don't know the patterns, we don't know the rules, how addition works, but we have some data that 1 gives 2. So there are two inputs, 1 and output is 2. Let's say there are like uh, let me take an example of XOR gate. Okay, or maybe a simpler one, OR gate. Yes, OR gate, right? Maybe few of you might have studied it in electronics. So OR gate means whenever both the inputs are true, then output would be true. So let's say there is input 1, that is A, and input 2, that is B, and there is output. Okay. So if I have both the inputs as false, okay, then what is going to be the output? False. Okay, then if one of them is true, then what is going to happen is it is going to get output as true. Okay, because this is OR gate, even if one of them is true, then we are going to say that output is true. So let's say the A is false and second is true, then the output is true. Now that is true, true, and output is true. Now see guys, we don't know what actually this, so we don't know actually how the OR gate works, but we know that there are two inputs. We know that there are two inputs and this is the output which comes. So we have, let's say we have some data and we have the answers to that data. We have the inputs, we have the outputs. Now, machine learning, if we give this data to machine learning, what it would generate it will generate a pattern or rule. It will generate a rule that this table shows the rule is A or B. This is the output. This is the output which would be generated by the machine learning. So now understand that machine is going to, or the software is going to extract patterns from the data. And this is what we mean to say when we say machine is learning. Okay. Very similar to how humans would learn by observing. Okay. By, let's say, okay, how many of you have like, uh, how many of you have observed or you have trained some dogs? Yes. How many have observed some trained dogs, or you have trained a dog or maybe a cat you have trained yourself? Yes. Anyone has done that? Yeah. Yes. Okay. That's nice to know. Or you might have seen some dogs getting trained, or you might have seen some dogs who have learned some training, right? So what do you do? You know, they learn. How do they learn? By observation, right? What they do is they do observe, right? Yes. Similar to kids, same way if you see the kids, okay, small kids, maybe few of you might be having small kids, so they observe and learn. So they observe a lot. They observe a lot. I've seen my kid, you know, when I speak very loudly, the kid is going to respond very loudly. So if I don't want my kid to be speaking loudly, what I have to do is I have to just tone down myself. Immediately I would see some changes in the kid. Okay, so they learn by observation. They learn by observation. They they have. So similarly, what happens here is there is observation. There are lots and lots and lots of data points we have, and there are answers we have, and by observing this, patterns are going to get extracted, and this is how machine is going to learn. Okay. Okay. So now machine learning, machine finds the pattern in the input. This pattern is mapped to certain output. So understand that whenever we are going to find a pattern, that pattern is mapped to a certain output, that if something like this comes, this is the output. Okay. So we get a pattern and we map it to output. Yeah, like guys, tell me, if I'm supposed to discriminate, I'm supposed to find out whether some picture is of a dog or not, or maybe whether I'm supposed to find out whether dog or cat. Yes. Can you tell me some features by which I can discriminate how to find whether the image is of dog or cat? Just give me, tell me some patterns. Might have observed some patterns, right? Size, head, height. Yeah, yes. Dog barks, wonderful, very nice. Okay, there are so many sound. Yeah, the cat sound is very different. Meow. I just had, just before this session, there was a cat visiting our IACSD. Obviously, she will not understand machine learning, but yeah, she was visiting us. So then there is a dog. Yeah, cat sleeps a lot. Okay, maybe Ajinkya has a cat. And dog tail is always, वो बोलते हैं ना, कुत्ते की दुम टेढ़ी की टेढ़ी. Okay, so and cats have straight tail, you know, especially when they are angry, and their tails become very straight. Yeah, their tail, then their, even the patterns of their, you know, kind of the nose they have, like dogs will have a nose which is protruding, or paws. Yeah, yes, there. So there are patterns, right? So the point is that there are patterns. Yes, behavior. Yes. So the point is there is pattern in their behavior, in their size, in their tail, in their looks. And what we are doing is all of this, we map it to the output. We map it to the output that, okay, this is a dog. And then this kind of stuff is there. This is a cat. Okay, this kind of sound it makes, then it is a cat. This kind of sound it makes, then it is a dog. Okay. So are you understanding? So what machine learning does, it finds the patterns in the input data and patterns are mapped to certain output. Okay. And this is how machine is going to learn. So then using the pattern and mapping, machine can predict the output for new inputs. So now what happens once the learning is done for new inputs, when there would be a new image. So already we have learned some pattern that if something looks like this or something is barking, then it is a dog. And we predict the output. For the new inputs, we predict the output based on these patterns and their mappings. Okay. Are you understanding this point? Okay. And this pattern and mapping is known as knowledge. So this is learning. This is what is the learning, and this is what is the knowledge, which is in the machine learning. When we say that there would be some knowledge part, so this is the knowledge part, that the patterns, how to find the patterns from the data and how to map it to the output. These things are, you know, kind of called as knowledge. Okay. Another example, diabetic patient. So now you can think about diabetic patient or corona patients. There can be some symptoms and you can say that it's corona or something like this. Okay. There can be other ways where you can say there is a pattern and output. Can any of the participants give me another example other than these examples which I have given, like where you would see from the data you're supposed to extract patterns and map it to the output, and based on that we can do the predictions, like I gave the example of dogs or cats, or even about the diabetes patients. We can think about from the BP level, sugar level and all that, we can predict the diabetes. So tell me, give me some examples. Okay, stock market. Okay, that's a big thing actually. Traffic, if vehicle crosses white line, yes, okay, that's a pattern. Okay, cancer prediction, weather prediction, yeah, we generally do this. Okay, weather prediction, अरे हाँ आज तो clear लग रहा है, आज बादल नहीं लग रहे, तो maybe आज बारिश नहीं होगा. So we do that, right? We do that quite many times. Or maybe it's a sunny day, so maybe I don't require my sweater with me. It would be warm today. Consistency in academic scores, yeah, you predict, okay, percentage, or you predict the academic scores of people. AI chatbots, yeah, chatbots are going to predict what is the answer of this. Result analysis, yeah. Next word input by the user, yes, yes, wonderful, wonderful. So next word prediction, what would be the next word? They have suggestions, there's suggestions in Google. You might see the suggestions, or even when you type things, then even other things like keyboards and all, they give suggestions because observing your general pattern. Maybe let's say you say thank and immediately you comes. Sales prediction, wonderful. Fraud detection, yes, yes, fraud detection, Abhijit, wonderful. Cricket match outcomes. Fertility, wow, that's wonderful, Omkar. um yeah, fertility, birth rate, age wise fertility, yeah, Chetna. That's nice. Nice use cases you're giving. Wonderful kind of application. So that's nice to know that. Very good. Wonderful. So yes, many places we can apply this, machine learning. Why machine learning? So now the question comes that, okay, guys, we have been doing so much of programming for, people are there, computers are there is programming happening. There are Excel sheets, there are PPTs. Why do we learn machine learning? Why we need, um, yeah, Chandana, I'm sorry, I did not get your question. Can you explain one of the examples for this? Yeah, which one?
Sir, you are telling, right, you are explaining machine learning like diabetic patient.
Hmm.
Actually, I missed out with network issue. Can you explain me
Yeah,
once again?
actually, we discussed the cat and dog in detail, so I thought you would make out with the diabetic patient. Okay, so diabetic patient means, see, again, there is age, BP, and sugar level. So now there are various features like this. You can think about, um, you know, like if the age is high, there is a possibility of diabetes, or maybe there is uh, what the lineage, maybe your mother's mother, or maybe your parents, they have diabetes and something like that, and that is like, okay, kind of lineage you have. Okay, based on that also you can be predicted whether it is diabetic, patient can be diabetic or not. There are many such things. Maybe you are sweating a lot, maybe you want to drink a lot of water, or maybe you are gaining a lot of weight or losing a lot of weight. Okay, so there are parameters like this, we body mass index, and we parameters, like just like we said about dog and cat, there are various patterns. So similarly, there is pattern in sugar level. If the sugar level is greater than 200, then there is a high possibility that you have diabetes. Okay, or maybe if your BP is very high, then you take this unfortunate, actually this is unfortunate thing in allopathy, that if you start taking BP tablets, then you have very high chance that you would get a sugar. Or if you start doing treatment of sugar levels, it's a very high chance that you get BP. Okay, it's a somehow unfortunate kind of a cycle which is being observed in allopathic, uh, patients who strongly follow allopathy. This is a very very vicious cycle being observed. So yeah, maybe sometimes even even doctors, when you go to a diabetic clinic, so they ask you, do you take BP tablets? So then your treatment would be different. So there are patterns like this. So based on the diabetic patient, based on these patterns, again, we will find the patterns and we will map. Okay, if the pattern is like this is a diabetic patient. If pattern is not like this, it is a healthy patient like this. And then similarly, we will learn, and that would be our knowledge. And now when new patient comes, again, when there is a new patient, what we do is we would gather all these things, age, BP, sugar level, and other stuff. And based on the pattern of this, we would predict whether the person has diabetes or not. Okay, in very same way which we did use for the dogs and cats. Okay, basically you have to understand that there is a patterns getting extracted from the data, and they're mapped to certain outputs, and this is what is the knowledge, or this is what is the learning. And based on this learning, when the new input is going to come, it is going to do the predictions for the outputs. Okay, so that is a very brief overview of machine learning. So why machine learning? So understand that there is a lot of programming, there is a lot of mathematics, but there is one very important thing, that there's something known as deterministic and non-deterministic solutions. Okay, guys, quickly, I want some answers. If I say 2 plus 2, if I say 2 plus 2, what's the output? 4. It's fixed. Do any one of you think that maybe nahi sir 4.1 bhi hota hai kabhi kabhi? Have you seen sometimes 2.2 plus 2 giving 4.1? ऐसा कभी हुआ है? No, never. This never happens. Or have you seen 2 plus 2 giving maybe 3.5? ऐसा कभी नहीं होता है. You don't have, never have this doubt that okay, 2 plus 2 is ever going to be 4.1 or 3.5. You don't have this doubt. And this is called as deterministic solutions. Okay, guys, tell me, if I, okay, there is a button next to me. Okay, if I turn on the button, okay, if I turn on the button, will that button start the tube light? Yes or no? Tell me. If I turn on the button, will it start the tube light? Yes? Yes? Okay, that's good. That's good. Is there any condition behind that? Yes, Mohit, that's good. If there is electricity, yes, there is an assumption, there is electricity, then it works. Otherwise, and Mohit says that that button should be of the light. Otherwise, how it would turn on the light? That's nice, Mohit. Yes. So understand that deterministic things are there. There are deterministic things. Yes. The button should be working. Wonderful. Button should be working, right? Maybe if you have used that button for 10,000 times, maybe it is wear and tear. And bulb should be working. Wonderful. That's wonderful. That's nice. That's nice. So guys, see, this is what is non-deterministic. This is real life. In real life, when I say 2 plus 2, okay, yeah, we can think, okay, maybe it's 4. We have to think. Can we say in real life 2 plus 2 is 4? Okay, I will have to like think about it. Two people. I have two coders with me. I have two coders with me, and I get two more coders with me. Will they be equivalent to 4 coders? Maybe, maybe not. Maybe equivalent to 5, maybe equivalent to 10, maybe equivalent to very wonderful people. Yes? Yes or no? Guys, in real life, does this just the number 2 plus 2 coders is going to give me the answer 4? Doesn't make any sense, right? It depends. It depends. Do you know WhatsApp? How many of you know WhatsApp? Type 1 in the chat box. Do you know how many people run the WhatsApp company? Do you know when WhatsApp was formed, actually initially for initial 5-6 years, how many people ran that company for initial, I think 5-6 years? Do you know how many people are actually working with WhatsApp, in the sense the company has how many employees? Yes, Harshdeep, very nice. Initially, there were only 4 employees. Complete WhatsApp, everything of the software is handled by only 4 people. And then they got hired by Facebook. So they become 5 people. Okay. So that's all. So understand this very big software, in the sense there are so many features, so many people are working on it, and so many people are receiving message, sending message, and everything is being done by 5 people. Wow, that's great, na? If I get such 5 people, wow, that would be, how many of you would like to have such team of 5 people with you in your company? Let's say all of you start a company and you have such 5 people in your company. How many of you would like to have such 5 people? Type Y in the chat box. I will be the first person. Yeah. Yes. So they are not only 2 plus 2. They are not only 2 plus 2, right? There are more than 2 plus 2. Yes. They are much, much more than 2 plus 2. So understand, guys, in mathematics, in maths, what we have is we have deterministic things. In mathematics, in theory, we have deterministic things. 2 plus 2 is 4. But in real life, we have non-deterministic solutions. We have to work with non-deterministic things. Face detection. See, think about, I want to detect a face. Okay, I'm not great at drawing. Okay, I'm not great at drawing. So just assume this is a wonderful person. Okay, very nice person smiling at us. I mean, smiling. He's very happy to be here and smiling. Okay, so now think about this. I am doing a face detection system, and then okay, then just think about this. They, after 2 days, what happens is he has some beard. There was some beard. Maybe he starts styling his beard. Now again, maybe after 1 month, what happens is he grows his beard more. Maybe he has more beard. Maybe he It does kind of a pattern of beard. So now tell me, this face detection, can I say face detection? I have one photo of this person. I have one photo of this person. Okay, this person, I have one photo. Can person, I can say face detection equal to this photo and this photo should match, then only this person is allowed. Is it right? Tell me. Every day I have to look the same, exactly same I have to look. Otherwise you will not be detected. My God, that will be such a tension to me. Okay, every day my haircut should be exactly same. Every day my beard cut should be exactly same. Okay, maybe 0.0 nano centimeter every day. If it grows by few micrometer, then it doesn't recognize. So think about it. If I have such deterministic solution, if I have exact matching the photo, then only person will be allowed. It will be so tough. In real life, will this work? No, in real life, this won't work. In real life, you have to deal with non-deterministic solutions. You have to understand that it is not that you have to say 2 plus 2. No, this won't work. This won't work in real life. In real life, you have to have statistics. You have to say mean. You have to say average. You have to say median. You have to say mode. Yes? You have to think about patterns. You have to think about patterns, not 2 plus 2. Yeah? Are you able to understand this thing? Are you able to appreciate this thing? Why we need machine learning? Why we cannot write a program for this? Why we simply cannot write a program and do this thing? Why chatbot can be a simple program? Why it needs machine learning to run it? Are you understanding this thing? Okay. I hope you are appreciating. Yeah. So in real life, it is not that there are fixed things. You can't work in a fixed way. You can't work in a fixed way. Every day is a different day. Even if in morning I made so much preparations to come on time and start machine on time and everything. I reached the center at 9:40. 20 minutes early, I reached here to start the session at 10 o'clock. But then suddenly at 10 o'clock, there was an emergency condition where I had to spend 10 minutes. So I can't just say that, okay, no, I have to start the session at 10. What I should do? I cannot panic, okay? So this is real life. And you also waited for 10 minutes. Maybe everyone waited for 10 minutes for session to start. Why? Because this is real life. It's not that, okay, 10 o'clock means session should start. No, this real life. There is some ups, downs, and some things happen. Even if you plan everything well, how many of you have such kind of experience where you plan so many things and still there are some failures? Yes, so many of you, right? So many of you. This is right, always. It's like always. So something will happen wrong, or maybe something will happen right, something will go wrong. That is fine. That is real life. So similarly in machine learning, we have to deal with real life things, and that is non-deterministic solutions. They cannot be fixed solutions, and that's why we need statistics. That's why we need patterns. That's why we need to think about lots and lots of data. We cannot just work with one thing that, okay, this works like this. We cannot make a rule. Yes, we cannot just make a rule. It don't work. It doesn't work. Rules don't work. Remember that rules, they don't work if they are not set up in a non-deterministic way. We have to learn that rules will work if the rules are made in a non-deterministic way. They have to be given some flexibility, right? Other stuff like in our institution, we give flexibility that, okay, even if you come maybe 3-4 minutes late, it is still considered as 0 minutes late. There is some flexibility, okay, given. Okay, someday if you go a little bit early, maybe 2 minutes early, 5 minutes early because of something, it would be considered. Okay, it would be considered. So there needs to be some flexibility given. Okay, there cannot be 100% thing. So understand that 100% success every time. This is deterministic. This is 2 plus 2. Remember, this won't happen in real life. Obviously, our goal should be 100% success. Our goal. This is our goal. That's right. Our goal should be like this. But at the same time, in real life, we should know that this won't work. In real life, it is always non-deterministic. And non-deterministic, how many of you know rule of thermodynamics? If you don't know this rule, you should remember this rule of thermodynamics. No machine is 100% efficient. Remember this rule of thermodynamics. It's very crucial when you understand machine learning. If you want to apply machine learning really very efficiently, you have to remember this, that no machine is 100% efficient. No person, no human being is 100% efficient. You would be very successful in your life. Okay, you would be very peaceful in your life. You would be able to take a lot of practical decisions in your life. Okay, you would be able to apply machine learning in a very big way. Okay, so there is no machine, okay, which is 100% efficient. So thinking that after machine learning my software will be 100% successful, that is a wrong thing. It's a wrong thing. It's a wrong assumption. It's a wrong kind of a thing for look for. Yes, you should have a goal like, let's say 99%. Yeah, that's a very wonderful goal to have 99% performance. That's a very nice goal. So achievable, very practical, down to earth goal to have 99% success. Okay. But don't look for 100%. That's not possible. Okay. So guys, are you clear with this? What is deterministic solutions? What are non-deterministic solutions? Why we need machine learning? Why there is, in real life, everything is non-deterministic, like face detection, fingerprint. Someday, how many of you feel struggle with fingerprint scanners? How many of you struggle with fingerprint scanners? Yes, I struggle with fingerprint scanners. I have such a struggle with fingerprint scanner because my fingerprints somehow they have some different patterns every day. There's some problem. Yeah, Prasad says sometimes. Yeah, Vaishnavi says yes, she faces problem with fingerprints. Yeah. So yes, now we have to work with it. There are problems. We have to work with it. We have to understand that in real life there would be problems with our fingers. It's not that fingerprint scanner is going to 100% right. Okay, so that's when we are looking for machine learning solution, we have to think about non-deterministic way and not a deterministic way. This sets the background for understanding machine learning algorithms. If you understand these facts about machine learning or real life solutions, then you would be able to really apply machine learning, really will be able to understand machine learning and will be able to grasp the essence of the various algorithms being talked about. Machine learning applications, guys, there are n number of applications today like fingerprint scanners, share market analysis, iris scanner, number plate detection, diabetes detection, recommendation systems, IoT based prediction maintenance. Okay, guys, tell me something which you have seen around you. Okay, tell me in your real life, you've seen a machine learning application taking place. Tell me some application of machine learning which you use or YouTube recommendation. Yeah. Okay. Good. Anything else? Social media, searches on Google, Chat GPT. Wonderful. Very nice. Google search prompting, email spam filtering. Very nice. search engines, keyboard word prediction, reels, reels, fraud detection in banks. Wonderful. Very nice. Very nice examples. Yeah. So guys, are you getting a disturbing sound? Are you getting a disturbing screechy sound from coming from my background? How many of you are able to hear this a little bit? So there is a machine learning. Zoom is applying machine learning to cancel that noise. Tax deduction in auditing. Wow. Wow. Your name is Money and you're talking about tax? Money is talking about tax. Wow, that's great. Nice to know that. Very nice. Yes. So wonderful examples you're giving. Digital marketing, MLs, advertisements. Wonderful advertisements. Advertisements. Guys, understand even the Zoom is recording all you have guys joined this session. You would be getting lots and lots of advertisements based on this. Okay. AI companion in Zoom. Yeah, that's right. That's right, Ajinkya. Wonderful, wonderful. Very nice. Very nice. Wonderful. Can we turn it on? Wow. Ah, that's nice. Let's say we are discussing AI, so I think 5 minutes we should turn it on, enable. I have enabled it. Let's say what happens with this. AI component is on. AI component uses AI technology, which may include third-party models, host, blah, blah, blah. Does not use audio, video. AI generated contents may be inaccurate, misleading. Always check the accuracy. Got it. Okay. Was my name mentioned? What are the action items? Catch me up. Okay. Not much has happened since AI companion is turned on. Try again with after a few minutes. Okay, that's nice to know, AI companion. Thank you for your input. Okay, so I have turned on the AI companion. Let me see how the AI companion goes. So now we are discussing these applications of machine learning. Okay, there are various machine learning or applications like this AI companion, which we are trying to work on. Now, what is AI? What is ML? What is DL? Where do you stand? Okay, where do they stand? So see here, guys. AI is a very big, very broad kind of an area where, okay, it's a very huge, very large kind of a branch. Okay. And machine learning is a subset of AI. So understand that AI has a lot of things. Okay. Computers that can imitate human intelligence, behavior. There is robots. Okay. There are many things. Okay. AI is dealing with a very broad spectrum of things. Okay. Fuzzy logic comes in AI. Okay. Fuzzy logic comes, then genetic algorithms come in AI. Then machine learning is a subset of AI where we are talking about statistical algorithms. Okay, AI which is driven by statistics is machine learning. Okay, it's a sub branch of AI which is just dealing with statistical models. Okay, so there are various statistical models, and we would be seeing few of them in machine learning. And then if we further go ahead, deep learning is further kind of we would say that deep learning is further niche, which is subset of machine learning, which follows only neural networks. So deep learning, there is only neural networks is there. So obviously neural networks use statistics. Don't think that neural networks are not driven by statistics. Neural networks are heavily driven by statistics. We would be kind of giving you an understanding of ML algorithms in a way that when deep learning session starts, you would be able to connect them. You would be able to connect the dots. So don't think that just because deep learning is using neural networks, it is beyond statistics. Rather, there is a lot of innovation of deep learning which is around statistics, or which is the basis is statistics. Obviously, it is like a very big parallel system is working, and we are using huge compute power, and that's why what happens is that there are many deeper patterns getting extracted and deeper things are happening in deep learning, but that's not a big thing. Okay, that's not a big thing, but it is driven by stats. So deep learning is subset of machine learning. Okay. Okay. Now, so what is machine learning or deep learning model building flow? So, and let us try to understand this fact, that how a machine learning project works, or how when you are given some data, how actually your software is going to learn. Let's try to understand this fact, because if you understand this flow of data here, then many things would be clear for you about machine learning. Okay, you would get a very big kind of a bird's eye view to machine learning if you understand this thing. Okay, so the first thing is, we discussed that in machine learning, whatever we are supposed to do, what we do is, we have to have some kind of data. We have to have some kind of data. So when machine learning model is going to be trained, or we are creating a machine learning model, the first prerequisite is there needs to be data. Okay. So now let me see, because we are talking about data, so let me see what this AI companion has got the data. Okay. Okay, so this AI companion is saying that this meeting so far has focused on topic of AI and its various applications. Dr. Shantanu Pathak discussed the broad scope of AI, mentioning its ability to imitate human intelligence and behavior, as well as connection with fuzzy logic and genetic algorithms. He explained that machine learning is subset of AI driven by statistical algorithms, while deep learning is further subset that focuses solely on neural networks. Dr. Pathak emphasizes that deep learning is still rooted in statistics and highlighted the importance of understanding the flow of data in machine learning projects. Wow, that's quite good, AI companion. You have caught up with much of our data. So guys, you wanted to try out the AI companion. I tried it out for you. Okay. So yeah, that's quite decent one. How to disable this stuff now? Now the problem is, when you start it up, the trick is they don't want you to stop. They will not give you a kind of a setting to, I got the setting. Yes. Got the setting to disable it. Oh, disable the AI companion. You can follow the instructions within the software window. You are allowed to disable turn on AI. If you are unable to locate the option, I recommend referring to the software documentation. Oh my God. Why AI companion you are telling? Why you're not telling me that there is just a button setting, click on that button and I will be disabled? Why it doesn't tell me the exact thing? Why it has to, you know, why it is giving me a chakli answer? Okay, do you know how the chakli works? you know there are some people, they give a chakli answer. Do you know that? They want to collect that and add goal goal goal. ऐसे भी हो सकता है, ऐसे भी कर सकते हैं, ऐसा भी कर सकते हैं, ये भी हो सकता है. Chetna is saying, what's chakli? Okay, Chetna, yeah, I can understand that. I would draw it for you. It's a delicacy in north. Okay, uh, it's a delicacy in north. You can think about something kind of spiral shape. It's a spiral shape thing. Okay, Chetana, that is a spiral kind of thing. So this answer by the AI chatbot, okay, how to disable the AI companion is telling, go to the documentation and this and that and software interface. It's not telling that there is a setting button and you click on the setting and just turn me off. It is not telling it. It doesn't want you to turn it off. It is making you difficult. It is telling a spiral answer. Okay. So that is what a spiral answer or chakli answer. I hope you have understood it. Jalebi, another beautiful delicacy similar to chakli. Okay. Yeah, not a straight tone. Yeah, Chetna, that's right. It's not a straight answer. It's not a straight answer. Just tell it. Okay, just tell it. So the point is that data. So they are collecting data. We are collecting data as a data scientist, as a engineers working with machine learning. We want to have data. So data is the first step. Guys, yeah, indirect. Yes, indirect. So now understand that, guys, when we are getting the data, when we are talking about a project which is going to deal with machine learning or creating some machine learning application, so understand that without data, you can never have the project. Without data, there is no project. Okay. So first thing in your project, you should tell, okay, where is the data? See, I went to a customer. Okay. We had a very wonderful discussion with them, 4 or 5 hours. I went to a customer. They wanted to have a sales forecast. What would be my sales? They want to have a sales forecasting machine learning kind of algorithm. We went to them and we were telling, okay, see, I'm PhD, this is my colleague, he is also PhD, this is also that, and I have my CEO is kind of having 20 patents with us and this and that, and we're telling all machine learning blah blah blah, we're telling our compatibility and capabilities and this and that and our achievements. 4 or 5 hours we discussed. Then we asked the customer, can we show us the data? Can we see the data? They said, yeah. We have data. 4 rows. We have 4 rows. Last 4 months, we have a new company. Since last 4 months, we are collecting our sales data. And so based on the 4 rows, 4 data samples, we want to predict our sales. It was a big joke. It was a big joke. That day I learned that after that day, whenever I go to the client, first thing I say to the client that, where is your data? First tell me your data. Then only I will tell you whether machine learning is possible or not, whether what kind of machine learning you can do, what all things. So guys, remember, even if there is so much noise, everyone is talking about AI, everyone is talking about machine learning, but nobody is telling the truth that you need data. Without data, you can't do any machine learning. You only have biggest of the softwares. If you don't have data, your machine learning is not going to work. The first thing is data. First thing is data. Get the data. Bigger the data, I would say you should have optimal data. What I'm saying? Optimal data. It should not be too large, not too large, not too less. Not too large, nor too less. Understand, it should not be too less or it should not be too large. Okay. Sometimes too large things would be messy. So it should be optimal data. You should get some optimal data for yourself, and then only you can start your projects. Okay. Otherwise, your projects, they don't make any sense. Okay. Your customers, even if they are thinking, they're dreaming, they are willing everything, without that data, they can't do anything about machine learning. That's the truth. It's the truth. Wonderful. Ajinkya is saying, what is the optimal scale? We will discuss, Ajinkya. It depends. It depends on, it's a non-deterministic thing, Ajinkya. It depends on your goal. It depends on what kind of solution you are targeting, what kind of problem you are solving. We'll discuss this, Ajinkya. As we go ahead, we'll try to touch upon this point. What is optimal data for us? What is the optimal data for how we understand that now is a good data? This is a good data to start working on. Okay. So how to do that? So we would discuss very practical, down to earth solutions. We'll discuss about it. Okay. Yes. Overfitting less. Yeah. We would come to that as well. Bias and variance, overfitting, underfitting, and all that stuff. We would talk about that. So the first thing, remember what you require. The first thing is you require data. Okay. Now, when I say the first thing we require data, quality of the data. Yes. Ganesh, right. Quality of the data also matters. Okay. We will talk about that. Pre-processing. So to ensure the quality of the data, what we do is we do pre-processing the data. So the first thing is, when we get the data, the first step to do, okay, first thing to do is there is training and testing. Okay, training and testing. You have to divide the data into two parts, training and testing. Okay. So when you divide the data into two parts, the first part is the training part. And the first phase of your machine learning algorithm is called as training phase. Okay, in the training phase, you get the training data. Based on the training data, you do the pre-processing, you clean the training data, you understand that how to clean the data, you learn how to clean the data. Okay, I think somebody is turning on the video by mistake. I would request the participant to turn off their videos, please. Okay. We are purposefully not turning on our videos. Yes. So, yeah. So understand, first we have to understand how to clean the data based on the training data. Then we fix. So in the training phase, we fix the pre-processing steps. We fix these steps. We learn. So understand, here in pre-processing also there is learning taking place. It's not that learning only happens here. Learning is there in pre-processing, learning is there in feature selection, and learning is there in the model training. In all three phases, there is learning happening. Based on the training data, we are learning how to pre-process, how to clean, how to select the features, and how to train the model. Everything we are learning in the training. Okay. Yes. How to choose the algorithm, right? Okay. We would discuss that, Prasad. We would discuss that, how to choose the right algorithms. So now, pre-processing, there are various steps in pre-processing. Can some of you list me few pre-processing steps? What are the pre-processing steps you would like to tell me? Yes. How you would clean the data? What are the pre-processing needs to be done? I think I would share it on the whiteboard. Sorting, outliers, duplicates, null values, data cleaning. Yeah. Oh, what's happening? Yeah. So one of the steps of data cleaning, one of the steps of pre-processing is data cleaning. Okay, removing nulls, duplicates. Yes. Noisy. Yes. Removing noisy data, outliers. Yes. Noise. Yeah. Yeah. These are the types. Okay. These are the things of data cleaning. Okay. Duplicate data. Yeah. Null value. Yes. Transformation. Yes. Count and check. Data type checks. Wonderful. Verify. Verification. Like you need to verify the data. Like let's say check the number of columns. Maybe you expected 5 columns, but the input data is giving only 3 columns. There is something wrong in the input, or maybe the input API changed. Yeah, trimming, handling missing data, noisy data. Yeah, right. Yeah, that's right. That is part of cleaning. But then there is also data verification. So data verification means input data is in given format or not. Check the number of columns, check the type of the column. Like you were expecting, let's say, for example, you expecting age as a number, right? When I say, give me your age, tell me your age, you tend to say a number. But let's say someone may give, my age is, I'm young. My age is, I'm young. Yeah. Can somebody deny that? Yes. Ajay, I would answer your question in a minute. Huh? So yes, somebody may say my age is, I'm old, maybe I'm young, or maybe I'm a baby, something like that. So somebody may respond in this, which is, there's also an age, kind of age group. Yeah, it's an age group, young, old, maybe senior citizen or something like that. Yeah. Yeah, Ajinkya, you think numeric data will help. That's right. But then the user may not know it. Nah? So user may give this input. You may not be expecting that, but then, so you need to check the type. You need to check the type. Okay, I was expecting a number. Has the user given the number? You need to verify. Are you understanding the point? You need to verify your data. You need to verify your data that, okay, whatever coming is. Also, one more thing is you may need to compile data from multiple sources. Guys, understand that it is, don't think that data will come from only a single source or file or data set or database. Don't think that your data may come from only a single source. That would be a wrong assumption. Yes, there may be some files coming from text document, there may be some PDFs, there may be some CSV files, there may be some JSON files, there may be some XML files, there may be some HTML files, there may be some databases. So data may come from multiple sources. and you need to compile the data together, and like, okay, how the data matches, where the data fits in. You need to compile that and put it together. So that is also part of pre-processing. Don't neglect that. Especially today's industry is heavily talking about this, or rather your ETL. Yes, if you think about ETL pipelines in big data, you learned big data, right? Maybe last, or maybe uh, last to last thing. Yes, you learned about big data. Some of you who are participating in the complete course learned the big data, right? So in big data, there is something known as ETL pipelines. So they are talking about all these pre-processing. So today, machine learning or the industry has come up to a level where they are talking about pre-processing is not just cleaning the data or not just verifying the data, but actually also compiling the data from various sources and then organizing that data and then giving it to the uh, cleaning and everything. Okay. So this is just few steps of pre-processing. Okay. Now let me touch upon few of the pre-processing stuff. Okay, 2-3 stuff. I have talked about the compilation. I have talked about the data verification. Now let me touch upon the data cleaning. So removing nulls. So understand that whenever there are some data going to come to you, don't assume that everything people will fill the form complete way. No, there may be some missing values. There may be some values which people have not filled it. Okay, maybe they don't want to fill, like maybe there is a feedback and you're asked something, some question, you don't want to answer that question, so you are left it intentionally, you are left it blank. So that is a null value. So now as a null value, that's fine, we have to deal with such null values. Or there are duplicates. Maybe one person has given the response 2 times. Maybe the same person has given the same response 2 times. So how do we handle it? How do we remove the duplicates? Then outliers or noise. Outlier and noise, they are almost the same thing. Many times outlier or noisy data. There is one more name to this. They are also called as anomaly. Anomaly. So anomaly, noise, outliers, they are almost the same thing, almost the same. Okay. So what does it mean by extracting or removing outliers? Now I'll give an example, very simple example. Like, tell me, if you are talking about a company, there is a company, one company is there. Now you are doing analysis of salary. Okay, you're doing analysis of salary. Okay, so now you tell me, like, if there are employees. Okay, there are employees, so what would be the salaries? Let's say there are people with 10K salary, maybe 20K salary, maybe 40K salary, maybe 30K salary, maybe 10K. Again, there are 2 people of 10K, or maybe 2 people of 20K, maybe 3 people of 20K, maybe few more of 40K, maybe 40K salary can be of 4 or 5 people are there, okay, who are having 40K salary, like this. Okay, so guys, tell me, CEO, what will be the salary of CEO of this company? Think about it, rough kind of understanding. Yes, can somebody tell me? Yeah, maybe some 100K or something. Yeah, that's right, that's right. Okay, so yeah, so now you tell me, if I consider, if when I'm taking average, if I consider this salary of the CEO, will it be right thing to do? Will it be affecting the average? Yes or no? Tell me. Yes, it would affect. It would affect. So it's a good thing that you handle it separately. So this may cause a noise. This may be outlier. This may be anomaly. We have to understand that such things. So these are called as outliers. So extreme values, you can say. Okay. So I hope the person who asked the question has got the answer that basically noise means extreme values. Okay. Now there is a question for null values. If I get 20 to 30% null values, how should I do it? 20-30% null values are okay. You can fill them up. Okay. You don't need to remove the null values. You should fill them up. And generally industry standard is we fill it by median. So median is a wonderful way to fill the values. Okay. Because mean is susceptible to the outliers. If your data doesn't contain outliers, then maybe you can use mean. Okay. Like here, the average salary. See, if some employee has never not given the salary, and if I take average of all of these, then this salary is going to really not be right. The average of this will not be right. So average is mean is not really a good thing to fill the missing values because it is susceptible to getting diverted by outliers. So we recommend, industry recommends using median. Okay, median is a very good measure to fill the data. Okay, so that's how you can Prasad, you can fill your missing values, which are 20 to 30%. See, if you are supposed to drop a column, maybe 80% of them are nulls or something, then you can think about dropping a column. See, it depends, Prasad, case to case. We would have to see your data. How, like, I will give an example. It depends case to case. Why this? Oh, I'm sorry. Why this thing depends case to case is, see, think about, Prasad, like I'm telling you an example. Let's say I am collecting data about all PMs in the world. Okay, all the prime ministers in the world, I'm collecting their data and I'm asking them, what's your age? Okay, what's your favorite color, or something. So now few of people are responding, okay, my age is 50, my 60, and few of the participants, they're not really comfortable in answering this question, that what is their favorite color. They don't want to answer this question. Yes. So let's say you have 100 PMs. Let's assume you got the data from 100 PMs and only 20 PMs responded to their valid values, and 80% of them are nulls. So Prasad, tell me, what you do with these 20 values? Will you remove them? Will you just not consider them? Think about it. You would not remove them, right? Arey, come on, this is data of PM. This PM is talking about himself. It's very important data. Yes or no? Even if 20% data, but it's very important. Are you understanding the point, Prasad? So as a data scientist, you have to evaluate, you have to talk with your customer, you have to understand the use case, you have to understand what is the importance of that column. If that column is not important, then maybe you can, even if there are 10% 10% missing data, you can just drop it. Even if there is only 10% data, still you take a decision to drop it because anyway it's not a very good column. So it depends on the importance. Are you understanding? It's not that I can give you a straightforward answer to this, because as a data scientist, we have to develop that skill of understanding when to use which solution. It's not that there is a fixed approach for every project you do this. For every project you do this. No, it is not like this. Okay, Prasad, I hope I am conveying you my understanding. I hope Abhijit Dave got a better understanding, because he was trying to answer your questions, Prasad, right? So Abhijit, I hope you got a broad overview. Okay, so it's a much broader level. Don't think that, okay, every project I will apply this. If you do this, then you'd be in mess. You'd be in mess. Guys, since last 10 years, I have been into machine learning. I have been involved in I've been involved in various projects where I've done machine learning with Java, I've done machine learning with R programming, I've done machine learning with .NET, I have done machine learning with Python a lot. And there are many n number of projects we have handled. We have done machine learning with some kind of tools. So guys, understand that one thing we have to see, that data is reality. Data is a reality. So if you are collecting real data, it's a reality, and don't mess up with the reality. Don't ever think that always it is going to be like this, always it is going to be like this, then it won't work. You would be in completely a big mess. You would be frustrated after some time. You would think that, array, I learned so many things of machine learning, nothing is working. You would be frustrated. Understand that there is no fixed solution. There is no fixed solution, because data is reality. Data is reality. You need to be very flexible. You need to be very, very flexible. Sometimes they can be much more stranger than fiction, right? Somebody has heard this thing. Truth is stranger than fiction. So it sounds wonderful. In the theory lecture, it sounds wonderful. These are the steps of pre-processing. You do this, you do that, you do that. You know, that is theory, guys. But then in reality, it's a big, big mess out there. Okay, so if you are not flexible, if you are not going to be accommodative, if you are not going to be open-minded, you'll be frustrated. Very, very quickly you'd get frustrated, Prasad. Okay, so I'd suggest that your attitude towards the data should be open-minded. I'll tell you, okay. Should I tell you a story of this, how I learned this? Should I tell you a quick story? Are you interested? Stories? I know we have very less time, but a story. There was our client. We were working with one of our client who was a IVF hospital chain. We were working with a IVF hospital chain, and we are getting, maybe 16K plus data of IVF patients. Huge data, and 1500 plus columns. Yeah, the 1500 plus columns were spread across in 50 Excel files. It was like big mess out there. And I would tell you guys, out of this 1500 columns, not even, I would say, not even 15 columns, not even 1% columns I was supposed to understand. Means, in the sense, I am an engineer. I don't understand medical terminologies. Think about it. It was a big thing. We spent 1 month, daily 2 hours with the client. Daily 2 hours, 1 month we spent to understand just the names of the columns. It's a big effort, guys. Pre-processing is not, okay, chalo, okay, do this. It's a big effort, very large efforts. And guys, I'll tell you the key for success. Do you want to know the key for success? So see, this client, such huge data, and we spend so much amount of time on just understanding the names of the columns. See that the amount of effort, 60 hours. And we were telling team of two people. There were two people, 60 hours each. So it's 120 hours. 120 hours were invested just to understand the names of the columns. Think about it. Think about it. What level of pre-processing is needed? Don't take quick decisions. Okay, quick day. ये ऐसा ही होता है, ये ऐसा ही होता है, ये तो ऐसा ही, अरे मुझे पता है डायबिटीज, अरे आई नो डायबिटीज, ये शुगर लेवल ना डायबिटीज है, होता है ऐसा. People tend to do this, right? As a data scientist, as a machine learning engineer, never pass a statement like this. Arey, sugar level greater than this is diabetes. Arey, never. Be very careful. If you are speaking like this, arey, missing value है ना, delete कर दो. Be very careful. Do you know the background of the data? Have you studied the data? Have you understood the data? Have you understood the purpose of the client? Have you understood the problem statement? Then only take the decision. Without that, if you take a decision, you're going to be in mess. Should I tell you a key formula of success in ML? I'll tell you a key formula of success to ML. Key formula, I'll tell you. All these years, we have been working on many projects. Many projects. I mean, okay, guiding many projects and manually myself doing many projects. So the key formula, let's say your machine learning algorithm is giving 90%. You want to have 99%. How to do this? From 90% to 99%, how to do it? Key formula. Do you want to know it? Only two people want to know. That's interesting.
Quality data.
I'm sorry, somebody tried to speak. I could not catch it up. Yes. I'm sorry, somebody tried to speak.
Quality data. We need quality data actually.
Quality data. Okay, data quality. That's very nice point. Yes. Okay. Something else. Okay, quality data. Wonderful. So many of you want to learn, want to understand the key formula. Key formula is, it's not rocket science. It's very simple formula, but the thing is you need to be very careful about it, that spend 80% of your time, your budget, your resources, your people, everything, 80% on what? On two things, on pre-processing and feature selection. This is 80% of your project. Understand this. Pre-processing of the data and feature selection of the data. These are the most important stuff, which are going to be the key for your success. From 90%, they are going to take you to 99%. This is the key. Why ChatGPT is successful? Again, they are doing better feature selection. They are doing better pre-processing. That's why ChatGPT is successful. Okay. So understand this. You can't compromise on this. You can't compromise on this. You may learn a lot of machine learning. You may learn a lot of things. You may do a lot of GUI. May do a lot of GUI, but this doesn't work till the time you have this solid stuff. Pre-processing and feature selection. So if you spend 80% of your time, 80% of your energy, 80% of your budget, 80% of your people on pre-processing feature selection, I'm very much sure that you will be having better and better performances. Very soon you would be seeing success stories in ML. Very soon you would be seeing major dramatic changes in your machine learning algorithm working. Okay. So with this thing, I would like to take a break. Okay. Let's take a break of 5 minutes. Let's take a 5 minutes break and catch up. Okay. Freshen up yourself and come back. Okay, guys, are you back from the break? Type Y in the chat box, please. Here, come back from the break. If you come back from the break, just type Y in the chat box, please, so that we understand how many of you are back, so that we can continue the session. Okay, great. So we discussed the pre-processing stuff, and we also discussed the importance of pre-processing and feature selection. Now let's just quickly discuss what is feature selection. So guys, so now feature selection. So feature selection means we are extracting important parts of the data which represent a pattern. Understand, we are going to extract important parts of the data, okay, which represent a pattern. Like for example, let's say there are 100 columns, maybe 10 are very relevant, 10 relevant columns you would extract, okay. Or let's say there is an image with 100 by 100 pixels, so we would extract important region of the image, okay. We may extract important region of the image, or maybe we may extract important color pattern of the image, okay. So, or let's say there is text data, let's say there is text, so out of that maybe we will extract the important words. Okay, so that is what is a feature selection. That, okay, there's some important part of the data which we are going to extract, and then we are going to further apply machine learning on it. Or the algorithms, they're going to further get applied on it. Now understand here that this is, you know, going to be a very important step to have successful ML model. Okay. Understand one thing, that let's say I have some data with me. There's some data. Okay. Now I'm going to do machine learning. I'm going to create a machine learning model. A software will be doing some stuff. Now guys, tell me, if I create a machine learning model from this data first time, is it enough? Now, can I not do anything with this data? Or is it that I'm not going to get new data anytime that I can? So tell me, when I should update my model? When is the time to update my machine learning model? Tell me, when do we need to update the machine learning model? Yes. We can get new data, add features, okay. Annually, we can, okay, every year you get new data once a year. And then you create a new model, okay. What else? What should be the frequency of updating your model? Think about it. Do you know industry standard of, what is the industry standard for updating the 4 months or 1 month? Okay, that's quite close. 15 days, fortnightly. Every 15 days, we are going to get new data and we are going to update the machine learning model. So understand, guys, that, okay, when we are talking about feature selection, so it is, why it is very important is because whenever we are updating these every 15 days or maybe once a month or once in 6 months, whenever we are creating or updating our ML models, there may be features may change and maybe the patterns may change. So we have to keep a watch. It's not that once I have selected the features, then it is like that for whole lifetime, maybe for next 20 years, the same features are going to be there. No, it's not going to happen. You'll have to keep a watch on your new data. You'll have to keep on verifying the patterns of the new data. You keep on verifying that whatever features you have selected from the original training data are still applicable in the new data. There can be change of the pattern. Okay, I'll give an example. Okay. Okay, Ajinkya says, when we are talking about updating the model, what do you mean? I mean everything of this, Ajinkya. We will get new data, we'll get new training, we'll do pre-processing, we'll do feature selection, we will build a new model, and then we'll do predictions newly. Everything of this happens every 15 days. So it may require changes in pre-processing, programming. It may require changes in the feature selection. It depends on the data coming in. So that's what I'm going to explain you. Just see here. Like I'll give an example. Why this needs to be updated. Let's see example. Very simple example. Tell me, where do you go for shopping? Where do you go for shopping? Just answer me in one word. Where do you go for shopping? Store, shop, okay. Shop, okay. Mall, okay. Okay, malls, online, okay. Online, okay. Good. So tell me now, these are your answers. Tell me, if I ask 50 years back, 50 years back, I asked the same question, shopping. Where do you go for shopping? There was only one thing and no other option. Yes. Has the pattern changed? Same question. Market, yes. Shop or maybe market. Has the pattern changed? Same thing, same concept, same thing. You are asking, gathering the same data, whether you are going for shopping or not here, but the concept is very different. Yes, and this is known as concept drift. Concept drift changes the patterns in the data, known as data drift. And because there is data drift, you need to again and again do pre-processing, again and again do feature selection. You have to do them again and again. Are you understanding this point? Why you need to change the pre-processing? Why, Ajinkya, are you understanding why it is that okay, once I have done pre-processing, what's the need to change? Okay, people's concept are changing. Their concepts are changing. See, myself, if you ask me, go to class. If you tell me maybe in 2019, where I will go? When I am told by my HOD, go to class. Where I will go? I'll go to classroom. Right? Now where I am? Go to the class. Where I am online. Yeah. So the point is, understand there is changed pattern of the data. It's completely changed. Concept has changed. Learn this concept. If I tell you, learn this concept, what you will do if I tell you, okay, find out what is feature selection, what you will do, tell me. If I tell you, find out what is feature selection, what you will do? Google it or GPT it, okay? Or okay, Avinash says this is what he has understood, that yes, ask. Okay, Ajinkya, ask whom? Ajinkya, किसको पूछेगा? But ask whom? Manager, resource person. Okay, that's nice. Nice to know that. Abhijit says, go to the manager. Hey, I don't know, man. Come on, tell me what is feature selection. Arrange a training for me. Okay, good. Okay, that's nice. Ajinkya, call me for the training, huh? I would really tell you in details about feature selection. That's nice. That's nice. So the point is, guys, the point is the concepts are changing. Okay, concepts are changing, and that's why there are major changes. Think about fashion. Yeah, fashion trends and all that, they keep on changing. So inevitably, you have to change the way you are dealing with the data. You can't say that I would deal with the data the same way I was dealing with the data 50 years back. That's not possible. You can't deal with the data in same way. So you have to keep on updating your strategy for data. So need to keep on updating strategy for data handling, preprocessing, feature selection. Need to do that. Need to put a lot of efforts there. Okay. So now feature selection. The most important point of feature selection is extracting important points of data which represent the pattern. Okay. May it be columns, may it be pixels, may it be text. From any kind of data, you need to extract important parts of the data. That is feature selection. Okay. What are the algorithms for feature selection? So one is very popular algorithm, decision trees. Okay, decision tree, or you can say random forest or XGBoost. That's a way of feature selection. Then there is another upcoming algorithm coming at known as Boruta. Then there is a principal component analysis. In data analytics, have you learned about principal component analysis, PCA? In data analytics, have you heard this term, PCA? Must have heard it. So that's one of the ways of doing. Okay, and there is advanced PCA, that is ICA, integrated component analysis, which is further better compared to PCA. It's an advanced version of PCA, which is ICA. Okay. And there are lots of such things. There are many such algorithms which are used for doing feature selection. Okay. Okay, so these are some algorithms which are used for feature selection. Okay, there are many others. It's like I'm just kind of yeah, kind of thing like I'm trying to do is that I'm just trying to give you a brief idea, okay, of feature selection. Any other algorithm you want me to mention here? Anybody knows any other algorithm which obviously in deep learning, every layer potentially is doing feature selection. So it's like in deep learning, obviously you have more and more layers. So more layers, better feature selection, better output. So that's a key to deep learning, that you add more and more layers, more hidden layers, more and more. So better feature selection happens and better output you can get. So feature selection, okay, it's important. Yeah, okay, guys. We are going to talk about decision tree a bit. PCA you have already been talked about maybe in data analytics. Okay. Any question on this? Okay. Discuss random forest Boruta in further lecture. That would be ambitious in 10 hours. We are going to discuss about random forest and decision tree. We are going to discuss about these things, this thing, this thing, this thing. And then Boruta, it's it will take some time. Okay. Take some time. Okay. So I would suggest that you can explore it yourself. You can check out this. There's a, I think, very recent algorithm. Maybe 2019 it was introduced. In 2019 it came into being. So yeah. So you can explore. Yeah. What is more used in industry? What's the trend? Okay, wonderful. That's a question. Do you want to know the best algorithm for feature selection? How many of you want to know the best algorithm? How many of you want to know the best algorithm for feature selection? Okay. It seems that there are two active participants, three of them. Okay. Okay. Prasad is saying add us. Ashwini. Okay. There are a lot of them. A lot of them. So see, best algorithm for feature selection depends on the data. Depends on your data. So what is our strategy? What is the strategy is you take these algorithms, go ahead, get the results, apply these algorithms, get final results, and then decide which one to keep. Are you understanding? You need to compare them on toy data, okay? On some portion of the data. So for some part of the data, you would have to apply these algorithms, you would have to get the final results, and then you need to compare them. Okay, this is doing better, this is doing better for me. Because every data will bring new challenges, So you can't say that this is the best algorithm. See, I used to tell that best algorithm is this, XYZ algorithm is best. Maybe 4 or 5 years back, if you would have come to my lecture, I would have told, okay, XYZ algorithm is best algorithm. But actually later on, I understood many times it fails. Yes, Ajay says there would be time complexity. Yes, that's why you would have to apply it on a portion of the data, not all data. You would have to spend time. You would have to spend time on it. You would have to spend time on it, finding out which is the best algorithm. See, this is like, Ajay, if you want to write something and you're sharpening your pencil, is it worth it? Like, think about if you want to write something and I am changing my pen, which is a better pen. I am getting a better pen to write. So is it a good time investment? Ajay, that's an important time investment. So if you don't decide the right algorithm, maybe you'd end up doing something. You do something fast, but you don't know what exactly where it would lead to. You may not be sure about the results. Are you understanding the point, Ajay? So that's why it's important that you spend time on comparing the models. Don't be in hurry that this is the best thing, this is the best thing. No. My auntie used to say that this is the best thing. मेरे चाचा के मामा का ताऊजी का बेटे के लड़के के बेबी ने बताया मुझे कि भाई ये बेस्ट एल्गोरिदम है. Octopus selected this as the best algorithm. ये सब नहीं होता है, ये सब नहीं होता है. हर data, every data is new challenge. Can we give example of feature selection in retail data as an example, or any of you want? Okay, that's very wonderful example. Case study, let's talk about feature selection in retail. Maybe 1 or 2 examples. Okay, so in retail data, let's say there is sales data and you want to find top customers. Okay, you want to give some kind of offers to some top customers, few, maybe some 100 top customers, first 100 customers. Okay. Okay, brand, price. Yeah, I want to first find the top, how to find top customers. Tell me, how to find a top customer, who is the topmost customer? Think about it. For you, who is the most important customers? That's a problem. That's a problem statement. You want to predict the customer would buy or not. That's what is the important customer, those who are going to buy it from you, right? the important. Who buy the most? Number of transactions. Okay, one thing is number of transactions. Only number of transactions? Think about more. Number of transactions or buy, what is the buying pattern? Actually, who is going to buy? Yeah, there can be some, actually number of transaction is buying only. There is no other transaction than buying. Yes. Number of frequency, yes, frequency. There can be frequent visitors, there can be bulk buyers, or maybe regular buyers. Yes, bulk buyers, regular frequency buyers. Amount of purchasing, yeah, that's right. Total amount spent, yeah. Monetary value. Otherwise, some person may do 100 transactions but of 1 rupees. Yes. Age of customer depends on retail products. Wow. ये क्या है भाई? I did not get it. What do you mean? Can you explain?
Like when kids are coming in the mall, they buy chocolates or milkshake. Some they like product
So
out in
you
the mall.
say
Retail.
that, okay, that is like, no, but we are finding the important customer. So you mean to say that you need to understand what products they are buying. Okay.
Right.
That is the next thing. See, first thing is you understand what are the important customers, and then next thing is what these customers are buying.
Okay.
Right? Yeah,
Right.
isn't it? That would be the next thing. First thing we want to understand what are the important customers. So see, these are the important features. Are you understanding? These are the features. And how are we extracting these features? So what would be the data, raw data? If you say, what would be the raw data? It would be just transactions. Only transactions, right? Bill number, bill total, items, number of items, time, date. Yes, like this. Raw data, what the raw data will have? Raw data will only have bill number and bill total and all these things. And what are the features we are extracting? Are you understanding? We need to extract features, number of transactions, this frequency, bulk buys. So that is feature selection. We are extracting features. We are extracting some important parts of the data. Are these what are the customer who are bulk buying, who are frequently buying, who are monetary value, blah, blah, blah. Yes? Okay, got it? And out of this, now one more thing is, first thing is you are extracting these features. Now out of these features, which are the important features? Which features are most IMP? Maybe frequency, regularity, and monetary value. They call it as RFM matrix. In retail industry, they call it as RFM. Recency, that is frequency. No, sorry, recency means recent transaction. Frequency, how frequently this customer comes, and monetary value. So these are the three things which they think is the most important thing about the customer, rather than whether he is buying bulk or maybe he is what is the number of transactions. So these are the three things which are considered the most important things: recency, What was the last time he visited? Okay, recency, frequency, and monetary value. Okay. Okay, so these are kind of important features. So based on this, so out of many features like this, so how to extract features? So that is what we need algorithms for. Okay, so first thing is this raw data. Raw data, we need to extract the features. This would be your pre-processing. This you do by doing pre-processing. Okay, so after pre-processing, what you would get is this thing. After pre-processing, you are getting this. Out of this, which are the important features? And then you would say recency, frequency, monetary value. These are the most important features. So this is your feature selection. This is your feature selection. Okay. Okay. Are you understanding now? Also, can we expect top customers by advertising on multiple platforms? Yeah, that's right. There can be a lot of things. Can be a lot of things. Feature selection, we would do a case study. There it would be more clear. Okay, maybe the post-lunch session we'll be doing some case study. So there it would be more and more clear. Okay, so are you guys clear with the kind of what is feature selection? Or maybe I would give one more example. Maybe some people don't understand retail. I will give you one very practical, very down-to-earth example for which everybody may relate. How many of you want one more example? Type Y in the chat box of feature selection. What is pre-processing? What is feature selection? How many of you want one more example? Okay. So for that, and just take a actual data rather than just talking somewhere here and there. Let me just take actual data and talk about it so that it will be easier for me also and for you also to understand. I'm just opening the data. Just give me a minute. See, I have the data like this. What I would do is I'll just try to show it to you how. Okay, so here is some data that this is the bank data. Okay, it's a bank data, and they're talking about various things. Okay, so just look at the various columns. You just read the. Is it readable?
Yes, sir.
I think I would just
Yes, sir.
increase the font a bit. Yeah. Now maybe you. Okay, so there is age. What is the job? Like that. Okay, housing loan, is he taking job, marital status. This is the bank loan data. What is the chance that you would take a loan from a bank? Okay, So see here now, there is now what we want to predict. Prediction column is at the end actually. Yes or no, whether the person is going to buy, whether the person is going to take a loan, or maybe if he is taking a loan, whether he is going to pay back the loan or not. What is the chance that this person is going to pay back the loan? Okay, so this is what we want to say. So yes or no, whether the person is going to pay the loan back or not, what's the probability, or whether he will take the loan or not. Okay, so you can say that. Okay, so sales data. So age is 58, his job is in somewhere management, married, education is tertiary education, he has done something ahead of secondary education, he has done something ahead of secondary education. Is he a defaulter in some other loan somewhere? No. What is balance, current account balance? Has he taken a housing loan? Yes. So is there any other loan? No. So will he take another loan? So something like this. So when he was contacted 5 days back, he was contacted. Okay, and the duration of the call was these many number of seconds. Okay, so was he involved in the campaign? Did he take participation in the campaign? Yes, he was involved in the campaign. Previously, has he taken any loan or something like this? They have given some data. Now see here guys, that we have to understand that whether the person will take a loan or not. Okay, so out of this column, we want to predict whether he will take a loan, will he purchase a loan? Okay, will purchase a loan or not? Okay, so this question needs to be answered using these kind of columns. So what we would do is we would try to map the pattern, okay, of these columns. We would try to extract some pattern from these columns, and we would try to map it, okay, to yes or no outcome. So there are two outcomes. Some people are going to purchase and say yes, they would purchase the loan. Some people are going to say no. So we are going to extract patterns from these columns based on this data, and these patterns, based on these patterns, we are going to map it to yes or no. Okay. Are you guys able to see the annotations I'm making? Are you guys able to read the annotations? Is it visible, everything, whatever I'm doing? I'm drawing some kind of things. Yes, they are visible, na? Yeah.
Yes.
Sometimes they may not be, so I'm verifying. So understand that from these columns, we want to extract the pattern and say yes or no. Now, there may not be much of a relationship of some column with whether the person is going to purchase the loan or not. Okay, like whether he previously has a loan. Okay, maybe just let's assume in our bank we understand that even if the person is not having the loan previously, or he is having the loan previously, still it doesn't matter. He is open to take the loan or he is not open to take the loan. It doesn't matter whether he has the previous loan or not. He is going to take a loan or doesn't going to take a loan, doesn't matter. Okay, it's not dependent on this thing. In our bank, the customers are like this. So this feature won't be important for us. Or maybe one more thing is, maybe the balance of the customer may not really make sense, that okay, will he purchase the loan or not? Yes, in some cases maybe, but then in some cases may not be really, that balance dictates whether he will purchase a loan or not. Even if people have a lot of balance, they may not be like, they may still say that okay, I still want a loan. And maybe there are some people who don't have any balance, still they are like, no, I follow some principles in my finances. There are some principles I follow, and as a one of the very important principle of finance, I don't take loans. So even if my balance is zero, I will not take loan. I'd struggle. I will earn some money and then purchase, and not purchase a loan. So yeah, so balance may not be a motivating factor for taking a loan. Yeah, you may find out such patterns. So based on the patterns you are finding from the data, you would say that what is the important columns, which columns are important and which columns are not important. Okay, so this is what is going to happen. This is what is going to happen. So now understand that, okay, this feature selection, okay, it's like you need to try it out, you need to do multiple algorithms, you have to apply, and then you have to understand the performance, you know, how the different algorithms are affecting the performance, and then finally you need to choose the best amongst available. Okay, so this is what is the feature selection. I hope it is clear now. Yes, any quick clarification, any question about pre-processing feature selection? We have completed these two parts, obviously in brief. Okay, so let's move. Now, okay, okay, one last thing before we go ahead. The point is, now, once again, I'd repeat the steps from the beginning so that you get connected. So see, we have the data. Now the first phase of our machine learning thing is training. So in training, the first thing is pre-processing, then feature selection. Once we do this, then we are going to build a model. Actually, the algorithm, we are going to train the algorithm, we are going to select the algorithm, we are going to build a model. Okay, this is what is the training going to happen. So in training, first we have the training data, we do pre-processing, feature selection, model, we select the algorithm, we compare the algorithms, we select best of them, and then we develop a model. Now, what happens is after training, okay, after training, there is a phase of testing. So we want to verify whether whatever training has gone in, how much it has gone in. So we would give the test data to pre-processing. Now understand that in training data, pre-processing was learning. Now pre-processing has to happen automatically. Automatically pre-processing has to happen. And then automatically feature selection has to happen on the test data. And automatically now the test data after feature selection goes to the ML model, which is already built. Now test data never goes for training of the model. Test data is never given to train the model. Test data is only and solely given to test the model, to verify the model. So ML model, it goes and it generates the predictions. For the predictions, we generate the results, we compare, okay, we do the evaluation. So we will evaluate the results. Whatever are coming in the predictions, we will evaluate the results. That is what is going to happen in the testing phase. Okay, so training phase, you're going to give the data, training data, pre-processing, learn the pre-processing, fix the steps for pre-processing, then fix the steps for feature selection, and then develop the model, decide the algorithm, best algorithm, and then develop the model, finalize the model, then testing. Okay, you give the test data, you automatically do pre-processing, automatically do feature selection, and give it to the ML model, and then it should do the predictions. And these predictions we need to evaluate. We need to find out how good are the predictions of this particular machine learning model. Maybe we can use these evaluation to predict. Okay. So understand that these steps of pre-processing and feature selection, they would be same for testing and training. It won't happen that, okay, it won't happen that okay, pre-processing is done differently for training data and differently for test data. It won't work. You need to follow the same things for training and testing. Otherwise, you would get a very different patterns in the test data and your model may not be able to understand the test data. Okay. Now, after the test data, okay, the testing phase is clear. Everyone, are you clear with the testing phase? Any question on the testing phase? So you have the original data with you. Original data, you gather the original data for your project. You do the training. You go through all the steps of training. Then after that, you have the testing data with you. You test your trained model and you check what is the performance. If the performance is not up to the mark, again go to training, do better training, better pre-processing, better feature selection, better model you select, and try to increase the data. Okay, do better feature selection. Like this, you go through it. Again, you do testing, and once the model, ML model performance evaluation is up to the mark, what is going to happen is you would come up with new data. Now you are going to, this is customer. So now your customer is going to deal with your model. That customer is going to give the new data. Now let's say new customer comes and we want to predict whether he will buy the loan or not. So the data given by the customer is very similar to the test data. We give it to the pre-processing. Again, very same thing what we did for very same thing which we did for pre-processing. For test data, very same thing we do for okay new data which is given by the customer. Then then we would give it to the feature selection. And after feature selection, we will give it to the ML model and we will get the predictions and understand. Now these predictions are given back to the customer. Now we may not evaluate the predictions. We are going to show or display the predictions to the customer, give it back to the customer. Is this thing clear now? The complete flow of the project. Is this thing clear? That what is training phase, what is testing phase? Yes. Is it, what is the actual thing, how it is going to run? Okay, when the customer is going to deal with the model. Okay. Any question, any clarification on this? Any further explanation somebody wants? So understand, when we get the data from the customers directly, that is known as deployment. So you say, na, there you might have heard this word, deploy the ML model. What is deployment of machine learning model? Deployment. People call or tell this. So what is deployment is basically you are going to get the customer. You're going to get the data directly from the customer, and then you need to do the pre-processing, you need to do the feature selection, and then you need to do the predictions which are given directly to the customers. Okay. Okay. So let's move further. I don't know, there is some problem. Okay. Yes. Any publications are available related to this work? Can you suggest? I'm sorry, Aruna Kumari ji. Means what do you want? Latest machine learning publications. Do I know you? I seem to have seen your face. I don't remember now where I have interacted with you, but then seem to hear your name, Dr. Aruna Kumari ji. I have, maybe I have interacted with you before. So if you give me some exact thing, I will be able to help you more. Publications, yeah, there is a lot of things happening in ML today, and what I would suggest is, if you want to go further deeper in ML, you need to do hands-on. You need to do things. Okay. It should be hands-on. Okay. Yeah. So if you really work on some projects, Aruna Kumari ji, then you'll be able to get much deeper details, and then you can go to the publications. That would be my understanding, okay, for real life understanding of machine. Okay, training and testing. Now, training is learning, where we are going to find the patterns and mapping. Testing, test machine for unknown inputs, unknown to the user or user inputs. So understand, in testing, the data should not have been given to the algorithm beforehand. Testing data should be different than the training data. They should not be same. There should not be any overlap between training and test data. They should be different. But both of these data should come from the same distribution. Understand that both the data should be from same distribution, but they should not be overlapping. Okay, they should not be overlapping. Okay, otherwise we would be doing target leakage. So if we overlap the training and test data, then there would be target leakage and it would affect the performance. Okay, so if you leak the target, okay, it's just like for students, if we are going to evaluate the students for some XYZ thing, then now you have to see that, okay, you don't give exact same questions in the evaluation as the questions were there in the training. You don't give the same questions. Okay, otherwise what will happen is that already you have disclosed the paper, so then people are going to score very high. And what happens, they may score very high at your institute, but the problem is when they go out in the market, they would be weak. They'll not be able to crack the interviews. So understand that training and testing. So similarly with the kind of applications we may design for machine learning, your training and testing data should be very different, in the sense that there should not be any overlap, but they should come from same distribution. Okay. Okay. So how do we split this training and test data? How we can split this data? So there are two types of training and testing. Training testing split the data, K fold cross validation. So you can go through these things. Okay, these are very very simple concepts, very basic concepts. So I'm expecting you guys to go through it. What is K-fold cross validation and what is training testing split? Okay. So now, after the training and testing and after understanding the complete overview of machine learning project, now let us understand how a machine learns. Okay, the first thing, the question is how a machine learns. We already discussed few things. Yes, can somebody tell me, till now we discussed how a machine learns in some perspective. So can you briefly tell me how a machine is going to learn from the data? Yes. By patterns. Very good. Very good. From previous records. Okay. It will store the data and connect their relationship. Yes. It will store the data and connect some relationships for patterns. Yes. Very good. Very good. Nice understanding. Harshadeep is saying, or Harshadeep is saying, please explain training and testing types. See, Harshdeep, we want to cover a lot of things. Generally, I take this machine learning in 120 hours, generally. Sometimes 180 hours. So we hardly even have 18 hours here. We don't have even 12 hours, not even 10%. So Harshdeep, if you have clarifications, you can ask me personally. Okay. That would be nice to ask me personally. Okay. So now, where do you see learning taking place around you? Where you're seeing people learning, or where you're seeing softwares learning, or where you're seeing some other ways of learning? Yes. Give me some 1 or 2 examples. Already we have seen some examples, but still. You see dogs learning? Yes, even the street dogs now they follow signal. Have you seen street dogs waiting for the traffic to go away and then only they will cross? How many of you seen street dogs following signals? Yes? You have seen? No? Not seen? Yeah. Oh, not here. No, no. Here, I see. I see every day. There are many dogs who want to cross the street. They'll wait for all the traffic to stop. That is on the signal, and then they will cross. If the dog is on the signal. If the dog is in somewhere in between, it would just wait for all the traffic to pass, and then it would cross the road. In Bangalore, it's common. Yeah. Yes. It's a common thing. So understand that we see a lot of learning taking place, and how people learn. How people learn, how dogs learn. Yeah. Obviously, street dogs. Yeah. Ganesh Kumar. Yeah. Yeah, in cows also. Yeah, cows are much more disciplined. Yeah, I can understand. Observing, yes, by observing, by learning the pattern. Wonderful, very nice. So see, think about a kid. Now, how a kid learns. learns what is red color. Let's say I want to tell my kid what is a red color. What do you do? Tell me, what do I do to explain to my kid what is a red color? Should I tell the kid the physics theorem, the rule of red color? What is the frequency of the color? What is the what are the membranes in the eyes which detect red color? Tell me how I tell the kid. Show him the red color. Okay, wonderful. Point out to the red color objects. Okay, red color object. Now you tell me, should I do it once or twice or thrice? How many times? Showing the red color object, how many times I will have to do it? Regularly. Wonderful. Regularly. Maybe quite some time, maybe 100 times. Yes, maybe 100 times, maybe 10 times. I'm not sure. And repeat the same multiple instances. Very good. Multiple times. Repeat same thing many times. Right? And then they understand, oh, will they make mistakes? Till he can point out correctly. Perfect. They will make mistakes. Very nice, Ajinkya. It's not that I tell 10 times, then it would be perfect. They would make mistakes. So you correct them. You tell them in more details, you understand, make them understand. Because sometimes you just tell them this is red color, this is red color. Maybe there is a chair which is red color. And what happens is that they understand that chair is red. They don't understand red as a color. They think chair is red. So next time they see a chair, they will say this is red. Have you seen something like that happening? So you would have to give them example of red color in different objects. Not only that, okay, this is red chair, this is red chair, this is red chair. Then they will understand the chair is red. Yes? Have you seen something like that happening with the kids? Then next time they see a chair, they say this is red. That would be a wrong kind of understanding. So you have to make sure that you are conveying the color part of it, not the chair part of it. If there is a red ball and you just every day show the ball and say this is red, this is red, this is red, what will happen next time you show any ball? They will say this is red. So we have to understand that we have to take examples of variegated examples. We need variegated examples. Okay, need to take many different examples of different types. Okay. Now, when I'm going to do this, what is going to happen? The kid is going to extract some patterns and map it to red color, right? Yes. And this exactly is called as supervised learning. Okay, supervised learning. There is need of a supervisor. There is a need of a supervision. There is need of a human. So in supervised learning, there is need of human being. Okay, there's a need of human touch. Then only it would be supervised learning. And in unsupervised learning, there is no human involved, only data. We would see some examples of unsupervised learning as we go ahead. Okay, this is the major difference between supervised and unsupervised. So there are two types of machine learning. One is supervised learning, another is unsupervised learning. Okay, there are many others like reinforcement learning and semi-supervised learning and self-learning and many others. There are 12 plus methods of learning available, okay, by researchers. There are many methods of learning, but then today we are just talking about supervised and unsupervised, okay. They are, because they are most important ones. Understand that today in industry, 99% of the industry is talking about supervised learning. 99% of the machine learning you see around is using supervised learning, and 1% uses unsupervised learning. 1%. Okay. So guys, that's why this is so much important. That's why it is so much important that you understand machine learning as, okay, what is supervised learning, what is unsupervised learning, how do we do it, and all this stuff. Okay. Any question, any clarification on how a machine learns? Great. Now, what are the common machine learning tasks? Okay. I would be going through these tasks very briefly, and then what I would do is after the break. So I would be going through this complete presentation before the break. Once the presentation is complete, what we do is in the post lunch session, we will be taking on one by one task at a time, and in details we'll go one algorithm we'll take and what does that algorithm do and all such kind of things we will discuss. Okay. So that would happen post lunch. Right now, we would just briefly make you understand what are the different machine learning tasks. The first task is regression, where we are predicting a number. Okay, so it is a supervised task. Okay, regression. Anytime you hear a word regression, it is going to predict a number and it is supervised. Remember that. Predict a product price based on the raw material. Okay, that is a regression problem. Predict the age of the patient or predict the blood sugar level of the patient based on the age, and based on the other parameters, predict the blood sugar level, like that. So there are various algorithms for regression like linear regression, multivariate, polynomial, decision tree based regression, stochastic gradient descent regression, like that. Okay. Then there is classification, where we are talking about predicting a class or label. Okay. So in this case, we are basically trying to predict a class. Like think about predict a bank loan, whether the customer will be a defaulter or regular customer, or think about whether the image given is of a dog or not. Or maybe you want to find out audio. From the audio, you want to detect the person. So you want to classify. If there is a customer in the bank, you want to predict the whether he is using a platinum credit card or he's using gold credit card or he's using what. So so that kind of predictions. Okay, that is again classification. Okay, so this is supervised learning major tasks, regression and classification. There are many others, but then these are the two prominent. And then there is forecasting. Forecasting is again supervised, where we are going to predict the future values, mostly the numbers like share market forecasting, weather forecasting. So whenever we say forecasting, it is in the future. So understand, there is a very small difference between prediction and forecasting. What is that difference? Prediction is for today. Prediction is of current thing, but forecasting is of the future. Okay, so whenever a future is involved, then sales data forecast what will be the amount of sales happening. Guys, tell me whether it is prediction or forecasting. Sales data prediction, how much sales will happen next month. Whether it is forecasting or prediction. It's forecasting because we are talking of future. Okay, so like that, there is a subtle difference. Many people, they may call forecasting as prediction, prediction as forecasting. That is fine. Okay, but I'm just telling you in details. Now, guys, can you give me some example of where you will apply regression? Can you give me, like I have given an example that, okay, predict the product price. Can you give me example of regression where you're supposed to predict a number? Give me where you will apply regression. Yes. Which countries might win more gold medals in Olympics? Perfect. Manufacturing. Yes. Good. There are number predictions. So regression can be forecasting, or it can be forecasting of number or prediction of number. So that is fine. Manufacturing. Yes. Sales. What will be the salary package for a particular person based on the performance? Share market. Yes. Share market. Yeah. Like that, there can be many such examples, right? What can you give me some examples of classification, please? Me some example of classification where you're supposed to predict a class. Okay, product, yeah, voice recognition, good. Or about product, I'm sorry, Samir, I could not understand. Like make a product for young or children. Okay, yes. Okay. Predict whether this product will be purchased by young people or they will be purchased by children's. Mobile or specific brand usage. Okay, predict which mobile this particular person will buy. Spam email. Yes, very good example, Yogesh. Spam, whether the email is spam or not. Okay, that's good. Few more classification example: cancer or not, diabetes or not, terrorist, detect the terrorist or not, public transport or private transport based on the income. Very good. Transaction, whether it is a grocery, medicine or hotel transaction. Yes, Google Pay. Very good. House price. House price. See, Prasad, price is a number. If you're talking about price as a number, then it would be regression. But if you're talking about price as a class, that it would be very high price, medium price, low price, like this, then it would be classification, Prasad. Okay. So we have to understand that classification deals with the classes. Okay. And regression deals with the numbers. Sorry, Chetana, I'm not able to catch with you. What's that? Animal, yes. Credit rating. Rating is a number, Samir. So rating, you're talking about rating, it's a number, 1, 2. But then if you are not allowing 1.5 or something, if you're allowing rating as rating 1, you can either rate as 1 or 2 or 3 or 4 or 5. Only 5 choices. Out of 5, what the customer will rate. That comes under classification. Okay. Okay, that's good. So I'm understanding that you guys are clear with the classification concept. Multi-class classification, yes. Gender, okay. Based on the image, predict the gender. Based on the voice, predict the gender. Based on the X-ray, predict whether there is corona or not. Okay, there can be n such examples. Okay, so they are classification and regression. Now, then there is recommendation systems. You already know YouTube and Amazon and so many people they use. That is supervised learning. Again, recommend the best options possible. Methods like collaborative filtering are used here. Clustering, unsupervised learning, grouping similar items like k-means, dbScan are used. Then there is outlier detection. Now this fraud detection. So fraud detection, here we use unsupervised learning heavily. We use unsupervised learning, and sometimes even the supervised learning is used for fraud detection. Maybe if time permits, we will discuss the use case of fraud detection a bit. Let's see how things go. Okay, so fraud detection is unsupervised. Then find the extreme values or outliers or anomalies. Okay, algorithms like dbScan are used here. So see, we are going to go in more details of clustering and outlier detection. Okay, let's see, maybe today or tomorrow. Okay, as the session progresses, we'll see. Even the recommendation system we will discuss a bit. Then there are descriptive tasks like subgroup discovery. It is again supervised learning, like subpart tagging. Like think about, there is an image. Now in this image, so what kind of image you want me to draw? Yeah, maybe there is a tree, or maybe there are two trees. So see, now subgroup is, it is going to detect that there is a pattern here, there is a pattern here. These are the two subgroups, and there is another pattern here. There are three subgroups. So subgroup discovery is again supervised learning, and it extracts the subpart. Okay, you can think about subgroup discovery of customers, then part of speech tagging. Okay, multiple object detection in the same scene, like this. They are all subgroup discovery tasks. Then association rule discovery, that is an unsupervised learning method which is used for, have you seen this thing? Market basket analysis. Have you heard about this term, market basket analysis? Or you have heard the a priori algorithm? How many of you heard one of these terms? Market basket analysis or a priori algorithm? If you heard about them, okay. If you heard about them, then this is what it is. So association rule discovery is basically market basket analysis or a priori algorithm. We will be seeing that hopefully, let's say if time permits. But then it is unsupervised. It is unsupervised. It happens on its own. Obviously, we need to fine tune it. Okay. Okay. So now, how do I approach a machine learning project? A last bit, and we will take a break. How to approach an ML project? What is the question, problem being solved? What is the target? Then which ML task to select? So understand that based on the data you have, based on the problem or task you have to select one of the machine learning tasks. Which machine learning task you need to do? Then can data which is collected, can it solve the problem? So you need to do the feature selection and understand that, okay, are the features which I am collecting, are the data points which I am collecting, are they enough? Do I require more data, more complex data? Do I require more features? Do I require more rows? Do I require more columns? What more I need? Okay, so we need to understand that, and we need to answer this question. Is the data, number of samples and features enough? Feature selection, again, feature selection is going to tell you, is the data which we have, okay, is that enough? Okay, we would talk about it. Then how to measure the success? So understand, guys, that when you are talking about an ML project, evaluation measures are very, very important. How you are going to evaluate the project, like precision, recall, F1 score. Then there is, okay, various kind of graphs. Okay, there is accuracy. Okay, like that. Okay, so evaluation measures are also very important. And how this project interact with the users, GUI part is also important, because that is going to be like, okay, people are going to appreciate the GUI. Okay, if you don't have a proper GUI, they may not be able to appreciate you. Okay, or your project, they may not be able to appreciate your project. Okay. So guys, that's all from my side for this first session. We have introduced you to machine learning, given a bird's eye view of machine learning. Okay, so I hope many of the things, basic stuff is clear to you. Any clarification anybody has? Any quick question? I'm here for 1 or 2 minutes. Okay. So guys, we'll take a lunch break. Now it's 1:10, 2:10. Yeah. Is somebody speaking?
Sir, what could be the challenges to learn machine learning? Like whenever we are learning topics of certain complexities, like what could be the challenges and how to approach it?
Yeah, first challenge what I see is you should have a right motivation. You should answer yourself why you are learning this. There should be some good, strong motivation to learn machine learning. Otherwise, what is going to happen is you learn it, you try to learn it, and after some time you leave it. So first thing is you should have a right motivation, right goal set, and that is many times a challenge. To keep yourself motivated, you need that kind of thing. You need to set a goal. And second thing is you need to understand that there would be challenges. There would be challenges, but then the challenges you need to take help, and you need to address those challenges. You need to seek help and address those challenges, because challenges are there in every field. Challenges will come. So need to have that mindset, that okay, even if challenge comes, okay, let's say today I fail. Today, like I'll tell you, when I started learning statistics first time, it took me nearly 2 years to understand statistics. Okay, it took me a lot of time. But then it was struggle. Okay, I used to open the book. I used to think, okay, today I will learn statistics. Today I will study statistics, and then it would be boring. I'll just keep the book away. It happened a lot of times. It happened. I had to motivate myself. I had to keep goal in mind, right goal in mind, and so that is what is one major stumbling blocks. Another stumbling block is statistics. You need to be ready to understand statistics. Third thing is you need to be ready to understand programming. Okay, only theory, you will not be able to really apply machine learning. You will not be able to really understand how machine learning is working. So programming is, or get some tools, purchase some tools which would do it for you, but then you need to invest that money. Either you invest your skill of programming or you invest money in it. So either of the two. So that would be the next challenge.
Okay, sir.
I
Thank you, sir.
hope- Yeah, I have given a very bird's eye view of challenges. Yeah. Sachin was saying something. Or say something. Sachin Mane. Okay, so let's take a lunch break. Okay, and we would meet at 2:15. We would continue. Okay. The first session. Oh, sorry. So Omkar, this is my first session on ML concepts. I am biostatistician students. I have years. How to start learning? Some guidance. Okay, Omkar, no problem. When I would just join in after the lunch, okay, you be there maybe at 2 o'clock or 2:05. So what we do is we would personally discuss, Omkar. Okay, no issues. Yes, yes, Aruna Kumari ji, yeah, it's very useful for projects. Yeah. Okay, so thank you. Let's meet after lunch break.